Hello, in this video we will use matrix solution of power series regression for a saturation growth model. That data set makes up the saturation growth model where the values are approaching closer to 10. So we will use the trend line in the form of power series, and the equation will be equal to y equals b0 times x to the power b1. So series, trend line, and the type will be power series. Show this as label, and our equation becomes y equals 5.45 times x to the power 0.346. And we also show r squared, which is 0.835, the fitness of our trend line. So our b0 is 5.45. Our b1 is 0.346. We'll calculate this values using matrix solution and LINEST. First, we transform the equation to the linear form. This is the linear form. Y becomes ln y, b0 becomes ln b0, and x to the power b1, that's plus b1 ln x. Factoring out the matrices, the x matrix will be 1 comma ln x factored out, and the coefficients will be b ln b0 semicolon b1. So the 1 comma ln x matrix will be this matrix, while the ln b0 semicolon b1 will be this matrix. So we will calculate this values b1, ln b0, and b1 using the transform dataset. We transform the dataset into the linear form, which is array formula starting with the dependent variable y, ln of the y values. Next, the 1 comma ln x matrix. The first column will be 1, and the second column will be array formula, ln of the x values. Now that we have the dataset transform, we can enter the LINEST function from this dataset. LINEST data y data x. And we show the full statistics. Here we have r squared, which is 0.8345, rounded up as 0.835. Our b1, 0.34632, matches to our b1 here in the equation, 0.346. Our b0, it's not b0, but it's ln b0. So we have to calculate the b0 using exponent ln b0. That's 5.45, matches to our equation in the chart. You can also use the matrix solution. You begin with the P-Gerina inverse matrix, which is inverse M mult transpose of the X matrix, the 1 comma ln X matrix, and itself. Then we calculate the P-Gerina cofactor, which is M mult transpose of the 1 comma ln X matrix and the transform Y values. Now we can calculate the coefficients, which is M mult of the P-Gerina inverse and the P-Gerina cofactor. So we have 1.696 matches to our LINEST output, and 0.3463 matches also to our LINEST output. This completes the matrix solution of power series regression for a saturation growth model. We have used LINEST and the matrix